All right, three people, A, B, and C, if they work together, we can do 1 upon A plus 1 upon B plus 1 upon C is equal to 1 upon T. But here, two of them start working together and they leave after 2 days. Well, we'll do the same thing. 9, 10 and 15. So LCM of 9, 10 and 15 is 90. That would be our total work. Of course, we can take any multiple of 90 as well. We can take total work as 180 or 270 and answer will still come out to be the same. But we took 90 so as to simplify our calculation. So we'll keep it simple and stick with the LCM. Okay. Now A takes 9 days to finish 90 units of work. So A's rate of work would be 90 upon 9, 10 units per day. Rate of work of B in 1 day. In 10 days, B finishes 90 units of work. So in 1 day, B will be doing 9 units. And C will be doing 90 upon 15, that is 6 units. Now B and C start working together and A is not there during the start. So B and C, they can together do 15 units of work in 1 day. They leave after 2 days. That means in first 2 days, they must have done 15 into 2, 30 units in 2 days. Okay, B and C did 30 units of work in first 2 days. So out of 90, 30 is finished now, 60 unit remains, which A alone is going to finish. And A does 10 units in 1 day, 10 in 1 day. So 60 will be done in 60 upon 10, that is 6 days. Simple application of LCM approach. Now next question uses concepts of arithmetic progression. 15 men can do a work in 18 days. They start working together and starting from the second day, one person leaves the site every day. What percentage of work will be completed? So if I take total work as 18, let's say the total work is 18. So 15 men will be doing 18 units of work in 18 days. Okay. 15 men can do 18 units of work in 18 days. That means 15 men in 1 day, they will be doing 18 upon 18. 18 units in 18 days, that means 1 unit each day. So 15 men in 1 day will be doing 1 unit of work. And if I talk about one man must be doing 1 upon 15 unit each day. Okay. So the whole purpose of taking 18 as the total work, LCM as the total work, was to avoid fractions, but still we are getting fractions here. So instead of 18, I can take the total work as 15 into 18. Okay. This could be my total work. This is what 270. Now see what happens when I take total work as 270. Here I'll have 270. Now 15 men in 18 days, they do 270 units of work. So in 1 day, they will be doing 270 upon 18. That is 15 units of work. Now 15 men do 15 units of work in 1 day. One man will be doing 15 upon 15, that is 1 unit of work each day. Now starting from the second day, one person leaves the site every day. So let's draw a table of day versus work done. So on the first day, there were 15 men working and each one was doing 1 unit of work. So there was 15 unit of work being done on the first day. And on second day, 1 man left. So we are left with 14 men who will be doing 14 units of work. On third day, 13 units of work will be done. And this will go on till on 15th day, we will be left with one man who will be doing 1 unit of work. And 16th day onwards, there won't be any men remaining to do the work. So total work would be sum of all these numbers 1 plus 2 plus 3 plus 4 till 15. This is a natural number series. Total work would be 15 into 16 upon 2, n into n plus 1 by 2, which comes out to be 120 units. This is not our answer. We are asked what percent of work will be completed. So 120 units out of total 270 unit will be how much percent? This will come out to be 44.44%. Now moving on to the second part of this question. Starting from the second day, one person joins the site every day. Okay, few things are going to remain same. Total work will be 270 and one man in one day will be doing 1 unit of work. Okay. Second day onwards, one person joins the site every day. So now opposite is happening. We have day versus work here. On first day, we have 15 men working, doing 15 units of work. On second day, one man will join the site. So we will have 16 men working and 16 units of work will be done. On third day, 17 units of work will be done and so on till nth day. Now total work will be 15 plus 16 plus 17 and so on. We will go on till the sum of all these individual days work comes out to be greater than 270. Then only we will say that total work is finished now. Okay. If this summation is less than 270, then there will be still some work which remains undone. So this is an arithmetic series with number of terms as n and sum will be n by 2 into first term is 15 and 2 into 15 is 30, 2a plus n minus 1 into common difference is 1 and this should be greater than or equal to 270. Solve this, we will get n square plus 29n minus 540 is greater than or equal to 0. If I put n as 10 here, I will get 100 plus 290, that is 390, which is way less than 540. So this is not going to work. Let me put n as 13 here. N square will be 169. 29 into 13 would be 290 plus 87, that is 377. And this sum is 546, which is greater than 540. So overall this left hand side is greater than 0, So on 13th day, the work will get completed. Sum of these two terms is almost greater than 540 when I put n as 13. So if I put n as 12, this will be lesser than 540. Obviously, this is going to be less than 540. So n is equal to 13 is our answer. On 13th day, the work will be completed. Next, last but not the least, we have a very confusing question. I'll tell you in a while why it is a confusing question. Just pause and go through it once. A can do a piece of work in 14 days. B can do it in 21 days. They both start working together. In how many days will the work be completed? If A leaves 3 days before the completion of work. Now this can mean two things. Simply saying that A leaves 3 days before the completion would be an incomplete statement. Okay. This could mean two things. One, that A leaves 3 days before the scheduled completion, the day when the work is supposed to be completed. So A leaves 3 days before the scheduled completion. Or second case is when A leaves 3 days before the actual completion, the day on which the work actually gets completed. Okay. Let me explain to you the difference between these two cases with the help of this diagram. In first case, A leaves 3 days before the scheduled completion. Okay. Let's say this date is 12th date 12th day of the month, and A leaves 3 days before that. A leaves on 9th day. Okay, 3 days before the scheduled date. And now as A left, all the load is on B alone, and he will finish the remaining work after the scheduled date. Okay, this day, the actual completion day will be after 12th day of the month. In second case, A leaves 3 days before the actual completion of the work. Okay, so the scheduled date is somewhere here. This is 12th of the month. A leaves before the scheduled date, and now B alone will be working. We don't know how many days before 12th did A leave, but B alone will be working now, and the work will get completed on, let's say, this day. Now on this day, the actual completion day, if you look back, you will say that A left 3 days before. The day A left and the day work got completed are 3 days apart in this case. And in this case, the day A left and the day work got completed are more than 3 days apart. Okay. So this is the difference between these two cases. And stating just that A leaves 3 days before the completion of work would be incomplete information. Let's solve this first question, case 1. Okay, total work we can take as LCM of 14 and 21. Total work is 42. A takes 14 days to finish 42 work. So rate of A will be 3. Rate of B will be 42 upon 21, that is 2. And scheduled completion day would be, together they finish 5 units in one day. So 42 units will be finished in 42 upon 5, that is 8.4 days. 8.4 days after the start would be the scheduled completion day. Okay, if A did not leave, they would have finished the work in 8.4 days. But A left 3 days before. That means A left in 5.4 days. 8.4 minus 3 is 5.4 days. So A leaves in 5.4 days. In 5.4 days, both A and B were working, and in each day they were doing 5 units of work. So in 5.4 days, they must have done 5 into 5.4, that is 27 units of work. What remains is 42 minus 27, that is 15 units, which must be completed by B alone. Okay, 42 minus 27 is 15 units, which B alone will be doing now. And B does 2 units of work in one day, 2 in one day. So 15 will be done in 15 upon 2, that is 7.5 days. Okay, so total number of days the work took will be 5.4 days till here, and then 7.4 days after that. B alone took 7.4 days. So total days till actual completion would be 5.4 plus 7.4. 7.5, this is 7.5. So 5.4 plus 7.5, that is 12.9 days. Our answer is 12.9 days. Next we have case 2. A leaves 3 days before the actual completion of the work. And I am assuming total work as 42 only. Rate of A will be 3 and B will be 2. Okay. Let's say the work actually gets completed on nth day. Work gets completed in n days. Okay. That means A left in n minus 3 days. A left 3 days before the completion. So A left in n minus 3 days. That means for n minus 3 days, A and B worked together. And together they finished 5 units of work in one day. So in n minus 3 days, they must have done n minus 3 into 5 units. Okay. After that, for last 3 days, B alone worked. And in 3 days, B must have done 3 into his rate of work, that is 2. This much work B must have done in last 3 days. And this is the total work that they have done, which is equal to 42. So n will come out to be 51 upon 5, that is 10.2 days. Okay, this is how we solve questions when different people work for different durations. If only this statement was mentioned in the question that A leaves 3 days before the completion, then the question will be incomplete. Thank you for watching.